Hello my dear students, welcome to this next video. Here we have this question which was asked in GATE 2021 and the question is very simple based on differential equations. In fact, it is based on ordinary differential equations, so very simple question. So let us read the statement. So you have let y of x be a solution of the following initial value problem. So this is the problem they gave you and then they ask you what is the value of y of 4. Y at 4. Now looking at this equation, the very first thing that should come to your mind is that this is a Cauchy-Euler equation, right? Because if you don't know this thing, then it is very difficult to solve this ordinary differential equation. But once you have identified that this is a Cauchy-Euler equation, then you know the transformation and it is very simple job. Okay, so students, it's very important that you know the categorization of differential equations properly so that you can use the proper method. So here, how do we know that this is a Cauchy-Euler? Because with the second derivative we have a term of x square, and with the first derivative we have a term of x, and with the y we have a constant term, right? So here we know that the substitution that works is x is equal to e raised to power z, and I'm not deriving it here, but if you do this substitution, then you are changing your independent variable from x to z. Then your x square d2y by dx2 is replaced with theta into theta minus y, where theta is an operator dy by dz, and then your x dy by dx is replaced with theta y, right? So if we do that, so this is nothing but, if I open it, this is nothing but d2y by dz2 minus dy by dz, and this is dy by dz. So if I put it here in place of this, I have to put d2y by dz2 minus dy by dz, and in the second, in place of this, I have to put, including x, I have to put dy by dz, and then everything else is same. So now you see, with this kind of transformation, we have reduced it to the constant coefficients. So you can combine these two terms because they are same. So this is minus 5. So this is constant coefficients. This is second order ODE with constant coefficients, right? So for constant coefficients, we already know how to solve. So for that, we write the auxiliary equation, which is m square minus 5m plus 6 is equal to 0. So you make the factors, so you get m is equal to 3 and 2. So you write the solution, c1 e raised to power 3z plus c2 e raised to power 2z. Now e raised to power z is x. So we substitute here, so you'll get c1 x cube plus c2 x square, right? So this is the solution. But because this is an initial value problem, so we have to find out our c0 as well as c1 as well as c2. For that, we are going to use the conditions which are given. Y of 0 is 2, y of 2 is 0, and dy by dx at 2 is 4. So I'll compute the derivative here because I have to use the derivative. So if you compute the derivative, x cube derivative is 3x square and x square derivative is 2x. Right, now you put 2, if you put x is equal to 2 here, so you'll get y of 2 here. If you put x is equal to 2, you get 8c1 plus 4c2 equal to 0. And if you put x is equal to 2 here, you get 12c1 plus 4c2, and this is equal to 4. So now you have these two equations which you can solve for c1 and c2. And I did that, and I subtract, I got c1 is equal to 1, and then I substituted the value of c1 and I get c2 is equal to minus 2. So therefore the solution comes out to be this: y of x is equal to x cube minus 2x square. Now they asked me the value of y of 4, so I just put 4 in place of x, so that will be 4 cube minus 2 4 square, so that is 32. So the answer here would be 32. So this is 32, right? So you see, this is a very simple problem, but if you don't know about this Cauchy-Euler, then you cannot solve it, right? So Cauchy-Euler comes in the second chapter where you study the higher order differential equation with constant coefficients, right? There, this is one topic, that when you have a special form Cauchy-Euler where your coefficients are not constant, then how to convert it into constant coefficient. So Thank you for watching. If you have any doubt, please write in the comment box. Please share this video and subscribe to this channel. Happy learning!